Ever wonder what happens to your username and your credentials when you hit that login button? Where do they go and how they are handled inside your application? In this video, we're diving into the Spring authentication flow, starting by breaking down its architecture and exploring the Spring security source code to see how it all works step by step. So what do we mean when we talk about credentials? They're a piece of data that typically consists of the secret proof that a user provides to verify his identity. That could mean a password, a token, a certificate, or another type of identification. The credentials can be sent as a JSON payload in a POST request, in the request headers, for example, as a bearer token. This token can be a JWT, a POI token, or a Pazeto, or a username password pair using basic authentication, or as a cookie, especially with session-based authentication. Every incoming request goes through one or more filters in the security filter chain. These filters act like gatekeepers. Each one will check if it should handle the request based on how the credentials are sent. If the request contains a POST payload, let's say a JSON with a username or a password, the username password authenticator filter kicks in. If the request is sent instead using basic authentication, the basic authentication filter takes over. Or if the request uses a bearer token, like JWT, it's handled by bearer token authentication filter. Each filter knows how to extract the credentials and pass them down to the authentication pipeline. Once the correct filter processes the request, it creates an authentication object. This object includes two key things: the principal, who the user claims to be, like their username or user ID, and the credentials, their secret identity proof, such as password or a token. For example, in basic authentication or JWT-based authentication, the filter will typically create a username password authentication token. This username password authentication token is a common implementation of the authentication object interface. At this point, we often refer to interfaces to keep things high level and easier to follow as we walk through the authentication flow. If we continue, we'll find the authentication manager, an interface that's usually implemented by a provider manager. Its job is to find the right authentication provider for the type of authentication object that was created earlier. Depending on how the user logged in, this could be a DAO authentication provider for login forms and basic authentication, or a JWT authentication provider, which validates the JWT token sent in the authorization header as a bearer token. Each provider knows how to verify the credential for its specific type of authentication. The actual authentication logic will happen in the authentication provider. It will delegate two key tasks. First, to the user details service, which is responsible for loading user data, typically from a database. This interface has just one method: load user by username. If the user isn't found, Spring throws a username not found exception. Second, it will use a password encoder to verify the password against the stored version. If the user is successfully found and the credentials are valid, the authentication object is marked as authenticated and enriched with all the user's details, like their authorities and other useful information like the account status. This updated authenticated object is then passed back up to the chain from the authentication provider through the authentication manager, and finally back to the security filter chain. This is how Spring Security knows that this user is verified and what they are allowed to do. Once the username password authentication filter gets the authenticated object, it stores it in the security context, which holds the current user security information. This context is then saved in the security context folder using a third local variable. That means the authenticated user information is tied to the current thread that handles the request. Now let's see how all this looks in the Spring code. I've linked a simple demo called 00 filter chain in the description below. We run the application in debug mode and send a basic HTTP GET request to a simple hello controller endpoint. In this way, we can step through the entire authentication flow we just talked about, right inside the Spring Security source code. I'll grab the password, then use the curl command to hit the endpoint. We see that the request hits the basic authentication filter, and we go inside the doFilter internal method. Here, the filter processes the incoming request and creates an unauthenticated authentication object, specifically a username password authentication token that holds the credentials but isn't authenticated yet. This username password authentication token contains our principal, the credentials, an empty list of authorities, and the authenticated flag set to false, because at this point the user hasn't been verified yet. Next, the flow moves to the Authentication Manager, which calls authenticate on the authentication object. This process will return the same object, but now populated with all the user details like roles, permissions, and with the authenticated flag set to true. Finally, this authenticated object gets stored inside the security context holder, making the user security information available throughout the current request execution. But now let's dive into the actual implementation of the Authentication Manager, in our case, the Provider Manager. Inside the Authentication Manager Authenticate method, it locates the right provider for the job. In our case, that's the DAO Authentication Provider. The DAO authentication provider will retrieve the user by calling the load user by username method from the configured user details service. In our example, this is the in-memory user details, which holds user data directly in memory. If the username is not found, a username not found exception is thrown. The password from the authentication object is then sent to the password encoder, where it will extract the ID NUP prefix, meaning there is no encryption, which handles encoding and verifying the password against the stored one. The provider will make some final checks on the user, like in our case, if credentials are not expired, then the user is put in cache. If the password matches, the username password authentication token is then marked as successfully authenticated. Hopefully, you now have a clear picture on how your username and your password travel through a secure backend system. If you found this helpful, don't forget to like, subscribe, and hit the notification bell. Please let me know in the comments if you want me to cover anything special regarding Spring Security. Thank you for watching and see you next one.